show you, I think I've shown you before, but if you want to do this, like I spelled mahjong wrong. I typed in, you probably can't see it. I typed in chemistry mahjong, and of course it's wrong, but then it came up with, did you mean this one? So I did. And actually this one right here, the Stetson.edu, if you click there, then, and there's also the same mahjong game for the Apple and for the Android. But you can play it on a computer just like this. And it probably looks familiar because I showed you when we looked at elements. But now if you go ahead and you click, for instance, polyatomic ions, okay, let's go ahead and start a new game. Let's see how we do. Oh my gosh. All right, so phosphate is PO43 minus, and the name is phosphate. Okay, so that's kind of how they go. Chlorite looks like that. Where I thought I saw chlorite.
It's above it, I think. 3 above it.
3 above it? Thank you very much. So you can get the tiles to go and you have to match them.
Why is your mouse blinking?
Why is my mouse blinking? I don't know. Oh, maybe it's because this, it kind of looks like maybe because this timer. I don't know. But that's a thought. So, but in the meantime, this is what we're going to do. This is the game plan. So part 3 was very much kind of what we did yesterday in lab. So what I want to do is just kind of skip through some of that. And then we'll start part 4, kind of switching gears from ionic compounds to covalent compounds. And then Monday, don't forget that lab worksheet is due. And also there's some homework at the end of part 3. 2 of them are going to be extra credit. And then the other 4 are to turn in. So I'll kind of show you what that is at the end of part 3. And Thursday's lab will be another dry lab. Go ahead, while I'm thinking about Thursday's lab, I'll write it up here. Pretty much think of room 101 for Thursday's lab. Probably. Okay. Thursday's lab is another one where it's just paper and pencil. And then that puts your unit exam a week from Thursday, which I got as April 7th. So that's kind of what we got going on. Okay. So you'll see what I mean by just kind of skipping around. So some of the, I'm just kind of skipping right to this slide. Okay, so do you guys have the answers for these? Okay, so I'll give you, oh, I know, I thought we might go around the room. Katie's like, oh my gosh, you always start with me when you go around the room. But let's see how we do with these. So notice you're just supposed to have your periodic table handy. I see Katie's got hers handy, so have your periodic table handy. And so what do you think, Katie? What is the charge of sodium when it forms a cation? It is +1. Ding, ding, ding. Let me know if you have any questions. Okay, Aletha, what about oxygen?
-2.
-2. Okay, so how did you get -2?
Because it's in 6A, and so you have to add 2 electrons to get the octet.
It's in 6A. You add 2 electrons to get 8, so it's a -2. Very good. I'm liking it. Okay, Jessica, what about bromine?
-1.
Why is it -1?
It is a 7A element. So
7A.
it is, but you add an electron to the octet.
Pick up 1 electron, it becomes a -1. Cool. Awesome. I'm liking it. Okay, Caitlin, magnesium.
2.
It is a 2. Why is it a 2?
Because it's in the 2A column.
Because it's in the 2A column. Ding, ding, ding. Katie, nitrogen? -3. And I'm going to stop asking you why, so you know why. Very good. Awesome, awesome. Or if you don't know why, you can ask. So potassium, bless you.
+1.
Aletha, +1. Awesome. Back to Jessica, sulfur?
-2.
-2. I'm liking it. Caitlin, fluorine?
-1.
It is a -1. And then we're back to you, Katie. Calcium? +2. Is there one more? Yeah.
-3.
Phosphorus -3. Awesome, awesome, awesome. Okay, and then I skipped a bunch and went right to here. And it looks like I already have the answers up there. Maybe I don't. Okay. So, Jessica, just the potassium and the chlorine, so potassium's +1, chlorine's -1. So how would you write the neutral formula unit? KCl, I'm liking it. Crisscross, perfect. Okay, Caitlin, what if you had aluminum +3 and sulfur -2? What would the formula be?
Is it just ALS?
You crisscross, so Al gets the...
You switch the, okay.
Switch them.
AL2 and S3.
Yep, Al2S3, perfect. Okay, Katie, Br +3, sorry, Fe +3, bromine -1.
So FeBr3.
Yes, FeBr3, perfect. They're kind of fun. Aletha, what about silver and oxygen?
Ag2O.
Ag2O, perfect. And then back to you, Jessica. What if you have NH4 and F?
NH4F.
NH4F.
I can only do one.
Okay, well, maybe your time is coming. Okay, now these seem kind of silly, but I'd like to go around and fill these in. These are all metals, but, well, all but the last one. So you have to say, do you use Roman numerals or not? So, for instance, Katie, for calcium, do you use Roman numerals?
For which one?
For calcium. No, so it'd just be the word calcium. Perfect. What about potassium? Use Roman numerals?
No.
Nope, so it'd just be potassium. Jessica, barium? Nope, just be barium. So we're back to you, Katie. Lead? Do you use Roman numerals? Yes, you do. So what would the name be?
So
Lead 2. Yes, lead 2. Very good. Roman numeral 2. Perfect. And then obviously lead you do, so what would Aletha lead +4 be? Lead 4. Perfect. Now we're back again to you, Jessica. What's the name for sodium? Just sodium. Okay. Now we're back to you, Caitlin. What about aluminum? Do you use Roman numerals for aluminum? No, you don't. So it's why not?
It's like in the middle of the B column.
That's right. Aluminum is like right here.
Oh,
So,
okay.
but the middle of the B column you were talking about is our, where'd they go? This silver, cadmium, and zinc. So you're right on about that too. So yep, aluminum, no Roman numerals. Oh, speaking of, so Katie, cadmium, do we use Roman numerals? What? No, very good. That's the one that kind of gets me, and that's kind of in the middle of the B's. So it's just the word cadmium. How about magnesium, Aletha?
No.
No Roman numerals, just magnesium. And last one. So what's the name of this one? Ammonium. Very good. Perfect. Okay.
I think what you said yesterday was like if it has a U everywhere, a high UN, it doesn't use Roman numerals or something.
So yesterday I said if it's like you said, if it's those three in the middle, so if it's these guys, you don't use Roman numerals, but you also don't use Roman numerals for all of these and all of these, no Roman numerals, and all of these, no Roman numerals.
Is that just something we have to memorize?
Mm-hmm. Yep. Yep. And I know sometimes I've seen y'all kind of marking up your periodic table just to kind of help study. So, yep. Okay. So we got a continuation, looks like, Caitlin. What about iron? Do we use Roman numerals for iron? If you find it on the periodic table,
That's Fe, right?
right, it's Fe.
Yes.
Yes, we use Roman numerals. So what would the name of this Fe2 plus be?
Just iron 2.
Just iron 2, exactly. Awesome. Katie, what about the next one? Iron 3, perfect. Okay, Aletha, what about zinc?
Zinc.
Just zinc, that's exactly right. You'll find zinc in the B's, but there's 3 B's that you don't use Roman numerals. Perfect. What about copper, Jessica?
Just copper 2.
Copper 2, perfect. Caitlin, next one?
See, just copper.
Do we use Roman numerals? Copper 1. Very good. How about nickel, Katie? Nickel 2. I'm liking it. How about nickel, Aletha?
Nickel 3.
Nickel 3. How about silver, Jessica?
She's silver.
Just plain old silver. Okay, how about Hg is mercury? How about mercury, Caitlin? Do we use Roman numerals? Let's see. I always have a hard time. Yeah, there it is. It's 80, yeah. So do we use Roman numerals?
Yes.
Yes, we do. So what would this be?
Mercury 2.
Mercury 2, perfect. Now this one really shouldn't be on here, Katie, but it's a polyatomic ion. Do you remember what the name of this one is?
No. It's Mercury 1.
It is mercury 1. Yep. It's kind of the weird one on there. Awesome. Okay. And this one's already been done. Oh, wait a minute. Now okay. So let's skip. We already did all this. Okay, so where did we leave off? Okay, so Jessica, so here's how this goes. We have the names, or everybody, we have the names at the top there, and then we have 5 formulas here. Can you tell me which one is carbonate? CO3 negative 2. I'm liking it. So she said carbonate is right here. I agree. How about Caitlin? Which one is hydrogen carbonate?
Is it HCO3?
It is HCO3 minus 1. I'll choose a different color. Very good. Okay, Katie, which one is permanganate? MnO4. It is MnO4. Awesome. Aletha, which one's chromate?
CrO4.
CrO4. Yep. There's chromate and dichromate in the way I remember it. So chromate, you're right. Chromate is this one that only has 1 chromium. And so, Jessica, which one's dichromate?
The top left.
Yeah, the top left. Dichromate is right there. Perfect. Okay, so same deal. Starting with Caitlin. So Caitlin, which one is sulfide? Remember, IDE means just 1 atom.
Is it the first one?
Yep, it is the first one. Very good. Okay, Katie, which one's sulfite?
Is it the bottom one?
It is the bottom left one. Perfect. Okay, Aletha, which one's sulfate?
And then the top. SL4.
It is the top middle. Perfect. Jessica, which one's hydrogen sulfite?
HSO3.
Yep. HSO3. Perfect. And then last but not least, Caitlin, which one is hydrogen sulfate?
The one on the left.
Yep, the one on the left. I'm liking it. Perfect. I'm telling you, group test. Okay, I think we're getting close to the end here. So, Katie, which one is sulfide? It is the bottom left. Perfect. And then Aletha, which one is sulfate?
It's the top left.
Yep, top left with 4 oxygens. Jessica, which one's hydrogen sulfate?
HPO4. -2.
Yep, very good. Notice that between phosphate and hydrogen phosphate, notice the charge goes down 1. Perfect. And so last but not least, Caitlin, which one is dihydrogen phosphate?
The H2PO4.
Yeah, it is the H2PO4. And notice when we kick in 1 more hydrogen compared to the just 1 hydrogen, now 2 hydrogens, it goes down 1 more. Awesome. Okay. I guess we have just still more. So we're back to you, Katie. Which one is ammonium? It is NH4, NH4 plus. And then Aletha, which one's hydroxide?
OH.
OH minus, perfect. Jessica, which one's cyanide?
CN.
CN minus 1, perfect. And then Caitlin, which one is the hydride ion? Yeah, just H minus. We don't do much with the hydride ion in here. Okay, so this one, where I want you to break them up into their component ions. So we're back to you, Katie. So if you broke NaCl up, what would the Na be charge and what would the Cl charge be? Right, 1 and 1, perfect. So it'd be Na plus and Cl minus. Awesome. So what do you think about this one? Now sometimes when you run into these on a test, they almost look foreign to you. Okay, but remember it's always going to be the an ion and then the cat ion. Okay, and you need to look for a break here. And I'm just going to put the break right there. So Aletha, what would those cation and anion be? And then the charge? Like?
Is the NH4 plus 1.
Yep.
Okay, and then the NO3 side minus 1.
Perfect. Yep. NH4 plus 1, NO3 minus 1. Exactly. You're kind of dissecting it. And sometimes when you're working problems with ionic compounds or just compounds, just anything, sometimes it's good to dissect. Okay, Jessica, what about this one? It looks like A1N, but of course that's ALN. Sometimes students, like I said, they kind of look at this and it looks weird, but try to find the cation and the anion. So aluminum is plus 3 and N is a minus 3. Perfect. Yep. Does everybody see that? That's awesome. Okay, so Caitlin, what do you think about this one? So again, we're going to kind of look for the metal or the cation first, and then we're going to find the anion. So break it apart. Almost, not minus 3. Fe plus 3, perfect.
And BR. This is where we switch it,
Right.
Switch it
Br minus 1, exactly. So kind of, and we didn't talk about this yesterday. Sometimes you're given a formula like this, and if we need to write the name for FeBr3, you know the name has to have the charge of the Fe in it. So in order to come up with the charge, you kind of have to go backwards. Does everybody buy this? Very good. Okay, let's see, another one down here. Again, try to kind of dissect it. So we're back to you, Katie. So sometimes when I'm dissecting, in a sense, the metal can get kind of crazy. Do you know what SO3 is, what the charge of SO3 is? You kind of go backwards. So what's the charge of SO3?
2.
It is 2 negative. Yep. So 2 negative. Perfect. So it looks like, what do you think about this Hg2? I think it's got to be, let's see.
So it's mercury 1.
Yeah, that was going to be my point. Does that make sense? Why is it a plus 2?
Because it's mercury 1 and sulfate already has the 3. I mean sulfite.
Sulfite has the 3.
Both of the mercuries have plus 2.
Yeah. So the 2 by the Hg isn't representing a 2 being on the sulfate. It's just hydrogen, not it's
Mercury.
just mercury
Mhm.
1.
Right.
So it's just, yeah.
So kind of what I was thinking too is that like this thing, when somebody gave you the formula for the compound, it has to be neutral. And you already told me correctly that your sulfite is bringing a negative 2. So I guess my point, what I was trying to make, is you know that the Hg2 needs to bring a plus 2 to make it neutral. And then, like you were saying, we know that there's that silly polyatomic ion. It's one of my least favorite polyatomic ions. And it's the mercury 1 polyatomic cation. So we're all on the same page. Okay. Olitha? Okay, break that one down. Break it down.
A plus 1,
Mm.
minus
Yep.
1.
K plus 1, BR minus 1. Yep. So these, like I said, can kind of help you working problems sometimes. All right, Jessica, what about this one? LiNO2. Break it down.
Lithium plus one and nitrate,
I think it's nitrate, -1.
Nitrite.
nitrite.
Uh-huh. Yep.
Close enough.
You're close. Lithium
We
plus
just went over
1.
this yesterday, I'm doing
You're doing good. Get out those flashcards this weekend. Very good. Good. Caitlin, what about this one?
That's aluminum sulfate.
It's going to be aluminum sulfide, but then how do you break it up into its components?
AL2 S.
Remember, you're going to kind of reverse crisscross.
Alright, AL3 and S2.
Yep, Al plus 3, S 2 minus. And these we could find on the periodic table too. Katie, perfect. Ni plus 3, Cl minus 1. Awesome. And Aletha,
Hg plus 2, SO4 minus 2.
excellent. Do you see why she did that? Hg plus 2, SO4, 2 minus. Excellent. Okay, so these actually match up with, if you go back, you've actually written the component ions for these. So Jessica, what is the name of the first compound?
sodium chloride.
It is sodium chloride. Oh, perfect. So what about the name of the next compound? Now, I know you guys are new at these, Caitlin. For the second one, you have to give it a first name and a last name. So you guys are going to bone up on these. But Caitlin, do you remember what NH4 plus is? You're going to pass? It's ammonium. Ammonium. Do you remember what NO3 minus is? Okay, ammonium nitrate. Very good. So we're going to skip on over to you, Katie. What about the next one? It is aluminum nitride. Very good. What about this one, Aletha?
Iron 3 bromide.
Perfect. Iron 3 bromide. Awesome. And then Jessica, what about this one down here?
Mercury 1 sulfate.
Yes, sulfite. You got it. Mercury 1 sulfite. Perfect. Perfect, perfect. Okay, Caitlin, what do you think about the top one?
That's potassium and bromide.
Potassium bromide. Perfect. You got it. And then over to you, Katie. What about the next one? It is lithium nitrite. Perfect. Awesome. Aletha, the next one?
Aluminum sulfide.
Aluminum sulfide. Very good. Jessica, the next one?
Nickel 3 chloride.
Perfect. Nickel 3 chloride. Excellent. Okay, and the last one, Caitlin? Do you remember what Hg is?
Is that
Starts with letter M.
mercury?
Yep, that's mercury. And do you need to use Roman numerals?
Yes.
Yes. Why do you need to use Roman numerals?
Because mercury is
Yep, yep. Very good. Do you remember what the last name is, SO4?
just do SO4. Sulfite.
Sulfate.
Sulfate.
Very good. Mercury 2 sulfite. Sulfate. Oh, that got me. Awesome. I think we've done enough of these. Okay. Oh, let's just do this one, okay? So,
Already has the answers.
you already has the answers, like all the way across?
Not all the way across, just the first row.
Okay. So how about, Katie, how would you make for the second one? How would you make a neutral formula for calcium nitrate?
So CaN3 in the parentheses 2.
Very good. Any questions? CaNO3 in parentheses and then 2. Perfect. Okay, we have Aletha, aluminum chloride,
AlCl3.
AlCl3. Very good. So crisscrossing. So for this one, I usually, instead of calling it bicarbonate, I would probably call it hydrogen carbonate. But so what would the formula for this one be?
Ni parentheses HCO3 and then sub 3.
You got it. Ni, begin parentheses, HCO3, and then a 3 out there. Last but not least, Caitlin, what would be the formula for this one?
Ag2.
Yep.
And then O plus 1.
Mm-hmm. Well, it'd just be 1. Ag2O, or O1. Perfect. Excellent. I'm getting tired of these. Okay. Let's get to the assignment slide, all right? So on this, I debated about this because I know you already have something else that's due, but these are so fun. So the first 1, 2, 3, 4, 5, the first 5 are for sure due. If you want to do the other 2, you can get 10 extra credit points. So it looks like this. If you do this, these 2, you'll get 10 extra credit points. Good towards a fun day at the mall. No, good towards missed assignment points.
If you don't extra credit for the missed assignment points and you don't have any missed assignments, then what happens to it?
They just,
Kind of hang out until there is a missed
yeah,
assignment? Okay.
yeah. And so I went ahead and when I did do the grade book recently, I took, if you did miss an assignment and you had extra credit, I went ahead and threw them in there. So. Okay, so now I just want to do just a little bit into, not assignment slide or anything, no. But I do want to look at part 3 just briefly. Excuse me, you know what I mean, part 4 just briefly. So I'm hoping that you guys remembered when we had, and I don't know if we necessarily need to add anything to it, okay, but we had molecular and we had ionic compounds. We talked about, you know, the differences. Compounds, of course, we use chemical formulas to say what atoms are chemically joined together. And then somewhere in there we talked about molecular compounds have all covalent bonds. And I mean chemical bonds, covalent chemical bonds. And an ionic compound has at least one ionic bond. And we talked actually a lot about ions recently. An ionic bond is formed when electrons are transferred. And they're transferred, you guys are great at saying why they transferred, is because the atoms want to get a complete octet and all that. Well, we want to focus now on covalent bonds are when electrons are shared. And they're shared for the same reason they're transferred. They're shared to give atoms octets, a complete set of 8 electrons. So that's kind of setting the stage. So what is a covalent bond? It's a type of chemical bond connecting 2 atoms together where that chemical bond is electrons are shared. They may not be shared equally, but they're being shared. So like I said, when you talk about compounds, a molecular formula for a compound, and you guys did a homework assignment where you were given different formulas and you had to say which type of compound it was. All of the bonds within that molecule are covalent. And then this is kind of a review slide. That's kind of why I didn't mind hitting you with this on a Friday, to remember it back for next week's Monday. Because we said in our list of things, we said look for the metal, and if you find a metal, then your compound must be an ionic compound. If it's no metals, then actually all of your bonds are covalent bonds. Electrons are being shared, okay? And then this is kind of a review topic. You guys, on the homework I think I graded and gave back to you today, you guys did some delta chis, electronegativity differences, okay? So you guys did a good job looking at those Pauling or electronegativity values. You know, difference in electronegativity is the absolute value of the electronegativities of the two atoms that are being bonded together. And as this got large, what you guys told me is actually if it was greater than about 1.7, then your bond was ionic. So, but if it's less than 1.7, then the electrons are going to be shared. So delta chi less than 1.7 electrons are shared, i.e. it's a covalent bond. And that happens between nonmetals. So these are, speaking of nonmetals, these are the electronegativity values, sometimes called the Pauling values of the nonmetals, of some nonmetals. So that's all kind of review. And then we said electronegativity, actually, if you have a periodic table handy and focusing on just the group A elements, electronegativity generally increases as you go from left to right, and electronegativity increases as you go up. Very good. Okay, so like I said up here on the board, within molecular compounds, those covalent bonds, those sharing of electrons, that whole bit happens just so atoms can get a complete octet. And as they share, they like have joint custody of electrons. So I want to kind of probably finish things up here. I want to draw kind of the structure of water. And we'll be drawing Lewis structures on Thursday, but this is kind of how it works. So if you have a molecular compound like water is, of course oxygen is a nonmetal, and I told you consider hydrogen a nonmetal too. So it's a molecular compound. If we want to kind of draw what that looks like with the covalent bonds, we need to consider hydrogen. Okay, there are two hydrogen atoms, and hopefully you buy this, that there is one valence electron associated with each of those hydrogen atoms. Okay, so I have two electrons, two valence electrons bought collectively by hydrogen. And then for oxygen, I have one oxygen atom. And remember, so this right here, okay, how many valence electrons does an oxygen atom have? It has 6. And how'd you get that? It's in 6A. Perfect. So it has 6 valence electrons. So I have 6 electrons for oxygen. So when we draw Lewis structures on Thursday, do you see where actually for those 3 atoms within a water molecule, I have 2 plus 6. I have a total of 8 electrons that are going to be buzzing around, valence electrons. So let me kind of show you what water does. Okay, so let's see. We have an oxygen atom in the middle. You probably already figured this before. We have a bond here to the hydrogen, and we have another bond to the other hydrogen. But let's look a little closer at the electrons. So here's my oxygen atom. Aletha, you told me there's 6 valence electrons. So let's gonna do one of those Lewis dot structures. So here I'm going to do X's for my oxygen electrons. 1, 2, let's see, 3, 4, 5, 6. Okay, so there's my big oxygen atom. Oh my gosh, it's humongous. So what I mean by double dipping is I'm going to saddle a hydrogen up over here, and I'm going to saddle a hydrogen up on the east side, on the west and the east side. And I'm going to go ahead and use blue dots for the valence electron associated with the hydrogens. Okay, so now I've drawn in blue dots representing basically these electrons right here. So when the dust finally settles around a water molecule, I think of it as kind of like Venn diagrams, kind of overlapping, shared custody. So I can draw a red circle around all of the electrons that the oxygen has. Joint custody now of those 2 electrons from each of the hydrogens. And I'm going to switch to orange color, and I'm going to draw a circle around this west hydrogen. Notice it has joint custody of that X, that's the oxygen electron. And it has custody of the one it brought, and similar, it's kind of symmetrical over here with this hydrogen. Now we see that the oxygen has a complete octet. It has 8 electrons. How many electrons does each of the hydrogens have? Only 2. But what rare gas has 2 electrons? Helium, exactly. So with 2 electrons, it is like helium. It does have what we call a rare gas configuration. That's what we mean by kind of double dipping and sharing. I think that's how far I wanted to get. Okay? So keep all that in mind and have a good week.